Temperature changes in a system indicate energy changes. So for example, if we isolate this system from the surroundings and add heat to it, then the molecules are going to vibrate and gain kinetic energy because the temperature of this system is going to increase. And we call this an endothermic process because the system has gained energy from the surroundings. And here you have ice turning into water. Now in contrast, if heat is expelled to the environment, then the temperature of the system is going to decrease and the molecules lose energy. So therefore the intermolecular forces become more significant and water freezes into ice. So we call this here an exothermic process, where heat was expelled to the surroundings. And in contrast, when ice turns to water, we call this an endothermic process, where the system gains energy from the surroundings. And this can occur through the addition of heat or work being done on the system. So for example, if you compress this volume, then the system also gains energy. And similarly for a chemical reaction, where we have carbon monoxide molecules reacting with oxygen to yield carbon dioxide. So here you have the breaking of the bonds between oxygens and a formation of the bond with each carbon monoxide molecule. And this releases heat to the environment. So we call this an exothermic chemical reaction. The formation of a solution may be an endothermic or exothermic process, depending on the relative strengths of the intermolecular or interparticle interactions before and after the dissolution process. So for example, when salt dissolves in water, step 1 involves the breaking of the ionic bonds in the solute. So energy must be input into the system and equal to the lattice energy to break those bonds. And given energy is input into the system, this step is endothermic. Now step 2 involves the separation of the solvent or water molecules, and energy is required to weaken the intermolecular forces to make room for ions to react with the water molecules. So here energy is input into the system, and this step is also thereby endothermic. Now in step 3, new intermolecular forces are formed between the water molecules and the ions, being ion-dipole interactions. So therefore energy is expelled to the surroundings, and this step is exothermic. So note that interactions, not bonds, are formed because there's no electron transfer or sharing of electrons. And step 1 is called the lattice energy. And steps 2 and 3 are called the hydration energy. And the hydration energy is greater than the lattice energy. So therefore the net process is exothermic. And note that it takes more energy to form the ion-dipole interactions, then separating the solvent molecules. So the energy of step 3 is greater than that of step 2. And therefore the combined process of hydration is also exothermic.